Okay, continuing on in the red slice, we will be taking a look at binomial problems basic, and this is the first of a number of different binomial probability problems that you're going to be seeing in ALEKS, so we need to know how to recognize those. Let's read through the problem. Now it tells us that a rainstorm in Portland, Oregon has wiped out the electricity in about 7% of the households in the city. A management team in Portland has a big meeting tomorrow, and all 6 members of the team are hard at work in their separate households preparing their presentations. Now, what is the probability that none of them has lost electricity in his or her household? Assume that the locations are spread out so that loss of electricity is independent among their households. And then round the answer to 3 decimal places. Well, since this is a binomial problem and since there's going to be several of those, let's take a look at our notes and see what we have here. First thing I would remind you is that the word binomial basically means 2 names or 2 ways for a thing to happen. Now in this case we're looking at electricity, and electricity is either on or off. Flipping a coin is binomial because it either comes up heads or tails. The characteristic of a binomial problem is that there's only 2 possible outcomes. Now when you recognize that it is a binomial problem, we're going to identify some things, and particularly for the binomial basic, we have to have 4 different inputs to our formula and 4 different things that we need to identify. And so what I will always do is make a list, N, X, P, and Q, and then fill those in as we read the problem. N is our sample size. X is a number out of N that could be 0 up through N that we care about in some way, what the story's asking about. P is the probability of that thing happening, the probability I say that we care about. And then we have Q, or the complement of P. That's the probability that we don't care about. So for example up here, if we care about it raining, that probability might be 70%. So the probability then that it doesn't rain, what we don't care about happening, is 1 minus that, or 30%, 0.3 as a decimal. Then when we have those information, or those bits of data recognized in the problem, we simply plug into this formula. And the first part of this formula, as you might recognize, is the combination formula that we did in an earlier lesson. Now if you can do that with technology, fine. Otherwise go back and find the formula for combinations that you worked with in an earlier piece. Now back to our problem to identify our pieces. Now notice here that the electricity has wiped out the electricity in about 7% of the households. This number here is either P or Q. We have to watch it though, because when they give this percentage, this probability, it may be what we care about and it may not be. Sometimes ALEKS does it one way, sometimes another. So in this case, the 7% is the number of households, or the percent of households where electricity is wiped out. Notice that in our problem down below, it asks for the probability that none of them has lost electricity. So losing electricity and having one's electricity wiped out is the same thing. And so this 7%, or 0.07 expressed as a decimal, is P, the probability that we care about. So let's pencil that in on our notes here. So our probability that we care about, 7%, 0.07. Now immediately we can calculate the probability that we don't care about, which is going to be 1 minus 0.07, or 0.93. So we can get this much of it done by reading the first sentence. Let's keep going. Now a management team in Portland has this big meeting, and all 6 members, this is our total sample size, all 6 members are hard at work. So this is N, and so we'll go back, make a note here. N is 6. And let's go back and read a little farther here. All six members are hard at work preparing da-da-da-da. What is the probability that none of them has lost electricity? None of them. In other words, 0 out of the 6. So x, the number that we care about in this case, is 0. So let's go ahead and complete our form here and work out the answer to this problem. So we're going to have an x of 0, and then down below in our formula step, what we're going to do then is notice that the formula says calculate the probability of x, or in other words, what is the probability that none of them has lost electricity? Once again here, the combination formula, so that's going to be NC0 multiplied by P, the probability that we care about. In other words, in this case, losing electricity, which is 0.07, which we will raise then to the x power, or the 0 power. We'll multiply that times Q, which is 0.93, the probability that they don't lose power. Now notice that we raise this to the n minus x power, or 6 minus 0. So we can clean that up a little bit. We will have the combinations of 6 things, 0 at a time, multiplied times 0.07 raised to the 0 power. We can do this on the calculator, but you may recall from algebra that anything to the 0 power is 1. And then we're going to multiply by 0.93 to the 6 minus 0, which would be 6th power. So this is the work that we need to run through our calculator. In fact, we can do it all right here on our TI-83 or our TI-30XS, which is our favorite calculator for this course. Let's go over here and just enter this exactly: 0.6469901 and some other decimals. Let's jump over here to ALEKS real quick and see what it was they wanted by way of rounding. And we can see here they want us to round to 3 decimal places. So coming back here and looking at our answer, the third decimal place here is the 6. The next decimal is a 9. That's going to cause us to add 1 here in the third place. So our answer, 0.647 to 3 decimal places. Let's go ahead and put that in and see if ALEKS is happy. Okay, we are good here. Let me show you one last shortcut that we can do using the ALEKS calculator. So let me take a minute here and show you this. This is kind of neat. And you're going to use this binomial probability button here on the more advanced problems, the binomial advanced. But let's take a look.